Today I got a quick video for you. We will do a assembly program for the Arduino Mega, and we will blink an LED at different speed rates and also print the counter value through the Uart. So let's start with the project. Okay, so let's make a quick tour what we got in the project. So I got an assembler project right here in the Microchip Studio, and what we have here are some dependencies which you can view here. So that's just simple macros for the peripherals, and what we got here by default will be the main.asm. So in here you write your own code in the assembly. I also added an extension file, so also .asm. You can just add it by right clicking on the project and add. So new item and the .asm. So in the included file I got functions to set up the Uart and also transmit. Those are taken from the datasheet, so nothing very special. Okay, so now with the start of the main function, main file. So first of all, let's declare a few variables. So you use dsec and organize it at the start of the RAM. So those variables will be placed at the beginning of the RAM. So the variable, it is a byte and it holds up 2 bytes. So we will use it to store the maximum value of the counter. The variable 2, we will use it to transmit the data through the Uart. So that's in the transmit function. So right here I load the variable to a register R16, and then R16 is written to the Uart transmit buffer, register. Okay, so now as we got the variables declared right here, now we can start with the C-sec for organizing the instruction code. So at 0 we got the AVR interrupt vector. So in this example we will only use the reset handler. So starting up the microcontroller, we jump to a function. So our function is called start, and it's right here. And before start I include the functions ASM. So doing this is simply as copy everything here and paste it right here. So that's just a macro. So make a more clean code, and at the start function I set up the Uart, which is in the included file right here. Then I clean up some registers which I will use later. So now I clean up the counter value. Then to the R18 I write the maximum value that the CST variable will hold up from 0 to 9 in this case. And the next on to the for variable I write the R18, so we got 9 value written to it. So later in the program we will check up if the counter is in this value for resetting it back to 0. Okay, and now to the R21 I write the bit of the PB7 pin, so it is a value of this, and it is this value in binary, so the most significant bit is set to high. And we will use it for two purposes. So first of all, we enable the output of the PB7, so the onboard LED. Okay, and now we can at the startup clear the LED pin. So let's first of all clean the R18 and write the R18 to the port B. Okay, so as we got this done, so now we are in the main loop of the whole program. So right here we got checking of the first printing the counter as a ASCII digit right here. So we load the value of the variable to R16, then in the R17 we add 48. I mean, we load it with 48, and then to the R16 we add the R17. So now we got a ASCII charter, which is a digit, and then we store it to the variable 2, and next on we call the printing function. Next on we put to the variable 2 a new line charter, which is 10 decimal, and we print it again. Okay, now as we got it printed, now let's make a check on the counter value. So if it's overflown or it is lower than the 9, which we will compare. So we load it to the R16, we increment it, and now we will check if it's overflown. So let's and there's one catch. Let's first clear up the variable that holds the counter. So next on we will make a check if the variable is overflown. Then we will not do this instruction, but if it's not overflow, then we will write back the CST variable, which is incremented by 1 right here. Okay, so next on, now for the delay, we will use the R19, and the R19 will be a multiplier of the counter variable for the delay. And after this we make an exclusive OR with R18 and R21. So as you remember, in R21 we got the bit value for the LED, which is this value, and making an exclusive OR, we simply make a toggle to the LED, so PB7, by writing into the port B. Okay, so now as we got this done, next on we jump to the loop start. So first of all, there's a thing that some pairs of the registers work as a 16-bit variables. So for this example, the pair of R24 and R25 work as a 2-byte register, so 16 bits. So this is the lower half and this is the higher half. So we will next on decrement 1 from the pair. So if we got this whole value decremented to 0, then we can decrement R19. But if not, then we jump again here. So in here we decrement those two registers, and if we got it to 0, then we can do this instruction. So decrement R19, and right here we check if R19 is decremented to 0. If it is, then we can simply start all over again, so jumping to the main. But if it's not, then we have to do this instruction, so jumping to the loop start. So again we fill the two registers and decrement, and do the decrement of the R19 again. Okay, so let's change up a little bit of the program. So instead of counting from 0 to 9, let's count, for example, to 5. So it will blink a little bit faster. So right in here, to the maximum counter variable we write, okay, so let's write 5. Okay, save and compile. So it is done in no time. And if you're curious, checking up the ASF will result in nothing. There's nothing to add here, just for the looks. Okay, so now let's simply program it. Okay, so we got the AVR dudes, and let's first of all make a check. So yes, we are connected, so let's program it. Okay, so as you see, it blinks quite fast. So now let's check up the serial port, and the serial port is selected as this value. Okay, so now let's open it up. Okay, so as you see, it prints from 0 to 5 right here. So that definitely works. So yeah, the assembler is not that hard to do some program with, and it's really fast, and it's low size. So if you want to make a very precision application, this is the way to go. So thanks for watching. See you in the next one.